Okay, now let us start the first exercise. I'll solve all the examples as well as the questions. Before that, let me tell you one more point about sets. If you are supposed to write, let us say, a set of letters used in the word schools, right? You need to write a set of letters used in the word schools. So when I write this set, let us name this set as capital X. When I write this set, I'll write it like this: S, C, H, O. Then I'll not repeat the O inside the set, and then I'll write L, and then again I'll not repeat the S. Okay, so what does that mean? That the repetition is meaningless inside the set, because when I write this set, I just wanted to convey a message that O belongs to this set X, right? O belongs to set X. So this is the message that you get by looking at this. So the repetition doesn't mean anything. All right, when even if I write it, it will not be correct to write, let us say, if I write one more O. Now even if I ask you like how many elements are there, there are still the 5 elements: 1 2 3 4 5, right? So this O is meaningless here, so I don't have to write anything redundant inside it because it doesn't convey any meaning. So SCHOL. So first thing that we learned is repetition is not allowed inside the set. Second thing that we can learn from here, that or the message that I want to give to you, is that you can write this set in various ways. You can write this as SHOCL or LOCHS. All these are same because they convey the same meaning, that C belongs to this set X, L belongs to this set X, right? Even this conveys the same meaning. So the order in which the elements are written does not matter, right? So you can write the elements inside it in any order, but you don't have to repeat the elements. Okay, so this is what I wanted to say before starting the exercise. Okay. Also, in this particular example, I used capital letters inside to write the elements. You noticed? Why did I do that? In general, we do not use capital letters to write the elements, but it is not a it is not a rule that you can never use them, because I was given the elements in form of capital letters. These are the given elements that I had to use to form this set. So when I am given the capital letters, I can very well use them inside the brackets. Okay, so it doesn't it is not wrong to use capital letters inside it, but it is not a convention, or generally we don't do that. Okay, so let us start with the exercise. First example says write the solution set of this equation in roster form. So first of all, you should know how to solve a quadratic equation. This particular quadratic can be solved very easily by factorizing the middle term. So you can write it like this. Okay, so I factorize this middle term as 2x minus x. So if you take x common, you'll have x plus 2, then minus 1, x plus 2 equals 0. So the factorization that I get is x minus 1 into x plus 2 equals 0, and the solutions I get are 1, or this will give you minus 2. How do I get the solution? When this is equal to 0, this will mean either x minus 1 is equal to 0, which will give you solution x equal to 1, or x plus 2 equal to 0, which will give you solution x equal to minus 2. Because when the product of these two is equal to 0, so one of these has to be 0, right? So either this is 0 or this is 0. So you have got these two solutions. Now we need to write this solution set in roster form. So the solution set is, first element will be 1 and the other element will be minus 2. It doesn't matter whether the first is 1, you can write this as minus 2 comma 1, it will still be correct, right? So one of the elements will be 1, other will be minus 2, because these are the two solutions that I got for this particular equation. So I had to write in roster form, where you have to write the exact elements of the set. So this is the answer. Okay, so let us look at the next example. Write the set x, all values of x, such that, this column means such that x is a positive integer. So what are positive integers? This basic knowledge of numbers or the other things in mathematics, basic mathematics, should be there. So when you say positive integer, you mean 1, 2, 3, 4, 5 and so on. These are positive integers. Now I need to write all values of x such that it is a positive integer and square of this x is less than 40. So if I square these positive integers, that value should be less than 40. So you know from the general knowledge that up to 6, if I square this, if I square it, I'll get 36. If I square 7, I'll get 49. So you know obviously the answer is this set, right? So this will not be included in the answer. So your answer is these braces, and then you'll write 1, 2, 3, 4, 5, 6, because these are the positive integers and square of which is less than 40, right? This is what I had to write. So this is the solution set. So if I denote solution set by capital X, then it is equal to braces 1, 2, 3, 4, 5 and 6. Okay, otherwise what you can do is you can think it like this: x square is less than 40, so x will be less than square root of 40. Give me a moment. So x will be less than square root of 40, so which is 6 point something, right? 6 point something. So x will be less than 6 point something. Now x is a positive integer, right? So what are the integers less than 6 point something? So you will say first which is just lesser than 6 point something, the integer which is just lesser than 6 point something is 6. Another 5, 4, 3, 2, 1. Okay, before 1 you'll have another integer which is 0, but it is not a positive integer. So only positive integers that satisfy the conditions are these. Let us look at the next one. Write the set A in set builder form. So how do we write? We'll write this as braces, then I write x such that x is equal to, now I need to make some rule here. So that the rule should satisfy all these values. You should be able to get all these values from that rule. So what are the values? 1, 4, 9, 16, 25. If you look carefully at these values, these are just the squares of natural numbers: 1 squared, 2 squared, 3 squared, 4 squared, 5 squared and so on, right? So these are just the squares of natural numbers. So let me write it like this: x is equal to n squared, where n belongs to natural numbers, right? So if I write this much, then I would have written this set in set builder form. Okay, so x is such that x is equal to n square, where n belongs to natural numbers. Okay, because then there are dot dot dot, so it means it will continue after this. There will be 36, there will be 49 and so on. So I have mentioned n belongs to capital N, and I have not put any restrictions on it. It continues after 25 also, because in the question I was not given any kind of restrictions. If I have got the question like this: 1, 4, 9, 16, 25 and then these brackets, now I haven't got this dot 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 here. Okay, for this I'll have a different answer. For this, let us say I would have got the answer like this: x such that x is equal to n square, where n belongs to natural numbers. Then I'll have to define the restrictions that n is less than equal 5 and obviously it is greater than equal 1. So n has got only these values: 1, 2, 3, 4 and 5. Okay, so the square of it will have the values 1, 4, 9, 16 and 25. So this is the difference in these two answers, just because of these dots that were given in the question. So 1, 4, 9, 16, 25 and then there was dot 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 dot. Okay, so that is why these two answers are different. I hope you got the idea what I am trying to say here. Now looking at this set here, 1 by 2, 2 by 3, 3 by 4, what is the rule that is defining this? If you see the numerator and denominator, in the numerator if you have got 1, in the denominator you will have 2, numerator 2, denominator 3. So denominator is 1 more than the numerator, and in the numerator you have all these natural numbers, right? 1, 2, 3, 4. So if I write the rule like this, if let us say the answer set or the solution set is capital X, and X is such that X is equal to n upon n plus 1, because I've got 1 more than the numerator in the denominator. So I have defined this X, I have defined this rule as X equal to n by n plus 1. Now I have to define this n. N belongs to natural numbers. Obviously these are natural numbers, 1, 2, 3, 4, 5 and 6. Now up to how much like up to which natural number I have to go? So I'll restrict the values of n like this. N is less than equal 6 and obviously greater than equal 1, because the smallest natural number is obviously 1, so it will be obviously greater than or equal to 1 but less than or equal to 6. Now if you look at this, this is your answer. Now can you convert it into the roster form if you just see this rule? So obviously you should be able to do that, because n is a natural number and it belongs to 1, 2, 3, 4, it belongs to 1 to 6. So what can be the values of n, or what will be the values of n? 1, 2, 3, 4, 5, 6. Now if I put values of n here in this rule, so I'll get the values as, when I put n equal to 1 in the denominator, I'll get n plus 1, that is 2, right? Next value, when I put n equal to 2, so I'll get 2 by 3, then 3 by 4, then 4 by 5, then 5 by 6, and then 6 by 7. So apart from these values, I do not have any other values, so I'll close these brackets. So these are the values of x that I've defined by this formula here. So this is your answer. All right. Match each of the set on the left described in the roster form with the same set on the right described in the set filter form. So we should be able to see a set in roster form and we should be able to define a formula for that, and vice versa. If we see a formula, we should be able to write the elements in roster form. So let us see if we can do that. PRINCAL, these are the elements in this set. If you look at this word principal, obviously this is too obvious, right? So X is a letter of the word principal. Only difference in the letters written here and here are that letters are not repeated here, which is a characteristic of a set. Letters are not repeated in a set. So I is written only once here, otherwise, and P is written only once here, otherwise all other elements are written. So this obviously is matched with this answer. Okay, and then in the next set written in the roster form, I have got only one element inside, which is 0. Okay, so now let me see. Look at this. If x is an integer and x plus 1 is equal to 1, so if x plus 1 is equal to 1, then what will be x? X will be equal to 0. So x is an integer, 0 is obviously an integer. So this is matched with this answer. Okay, look at this. 1, 2, 3, 6, 9, 18. And when I look at this answer, x is a positive integer and is a divisor of 18. So obviously this is matched with the first one, because these elements that you see, all of these are factors of 18 or divisors of 18 and are positive integers. So yes, it is matched with A. 3 minus 3 is obviously then matched with B. Otherwise you can obtain it. This is x squared. So x squared minus 9 is equal to 0, which you can write it like this: x square equal to 9 or x is equal to plus minus 3. So minus 3 and plus 3. So this is matched with B. I hope it is clear to you. So 1 is matched with D, right? Similarly, you can write all the other answers. Okay, so let us move to the exercise.